welcome on stage. This is Senior Consultant Christian Dalsgaard at Danish Technological Institute. I assume Zachary?
Yeah, and hello everybody. I also have my colleague Zachary Davis in the lab.
Yep.
So
hello everybody. How are you doing?
and you're so good, Zach. We can see you, we can hear you. I can tell everybody that we have so amazing fun setting this up, and I hope that we can transfer that fun to you guys too.
This is the layout you wanted, then I would remove myself actually into the audience so you are displayed much bigger and sound is great.
Yeah.
The stage is yours. The stage is yours, guys. I move to the listeners.
All right. Thank
Enjoy.
you very much.
Okay. Yeah. We are 2 minutes ahead of schedule, probably the first time in a conference. My name is Christian Dalsgaard. I work at the Danish Technological Institute in Copenhagen, in Tostrup, near Copenhagen. I'm also chair of the Smart Textile Alliance in London. I have a long background into smart fabrics and the technologies about smart wearables. Zach, please introduce yourself to the audience before I start my presentation.
Mm-hmm. Yeah, my name is Zachary. I'm also team manager at the Danish Technological Institute, and I'm gonna give you a little tour after some words from Christian. Nice to meet you.
Yeah. And the agenda for today is that I'll start out just tell a bit more about the Danish Technological Institute and what kind of work we can do for you. Zach will show you the printing and electronics lab. We will switch back and hopefully I can also showcase some of the demos that we have on smart wearables and the trend in utilizing printed electronics in this segment. Finally, we can showcase a very nice application, a precure sleeve that is used to prevent muscle injury. But let me share my screen and do a PowerPoint presentation. And I can see that appears everything work. We have done the very short introduction. We're both from the Printed Electronics Group here in Copenhagen. I work mostly outreach on defining projects, see opportunities utilizing the capacity at smart textiles and printed electronics. And Zach is here as the team manager for the group. DTI is over 100 years old. It's a research and technology organization. It's approved by the Danish Ministry of Higher Education and Science. We have 4 locations here in Denmark. Mainly the headquarters is in Tostrup, which is close to Copenhagen, just a few minutes from the airport, and you can visit us very easy. We have a site in Aarhus, which I also work on because I live close to Aarhus. People that may know me is aware that I have my route in Aarhus. So I can jump into both Copenhagen and Aarhus very easily. We have a site in Odense, which is mainly on robotic, and robotic also influence printed electronics in areas like smart skins for the robot arm. So there's 100% a synergy between the work that we are doing and also the work that are doing on in Odense. In Skype, we have the agriculture division, and that will probably also be expanded in the future with a lot of the work that is currently done in central part of Aarhus. Zooming in, To the work here in Copenhagen, we have the Center for Nanomaterials, Nano Production and Microanalysis. It goes years back, already from the very early stages of doing nanotechnology and understanding nanotechnology. And there have been work in specific areas that are related to printed electronics in 2015 with developing nano ink, nano copper ink. And that's a huge breakthrough in printed electronics industry where we can substitute silver with copper. So that's a very central part of the capabilities here at the DTI is the nanomaterials development. We also have a huge setup analyzing all kind of material, surface analysis, material analysis, elements that are failures into materials or material behaviors can be analyzed with very sophisticated equipment. And then we have the advanced printing electronics division, and Zach will showcase you around in the lab so that you can get an impression of what kind of facilities we have here, and that's all available for you guys, either on a lease base to actually work on the equipment before you're doing the investment, or let us do the prototype for you with the expertise that are already here. But that's a very flexible setup. I just want to mention the various areas, and this is different from other. Many are specifically into printed electronics, but our heritage go back to the development of the ink and the formulation of the ink that are suitable for printing electronics. It's the very basic creation of nanoparticles. It's the formulation of ink that are suitable for screen printing, for inkjet printing. And then, of course, the printing elements, understanding what type of elements that can be printed and make sufficient substitutes for traditional electronics. And finally, doing the test. This is also hugely motivated on the green transition because printed electronics is a way of saving weight, saving materials, saving energy in production. So we also see the framework for doing printed electronics as a part of the sustainable growth that happens in Europe right now. But with this, I will stop my share screening, and then I will leave the floor to Zach and have him to show around in the lab.
All right, thank you, Christian, for the nice introduction to what we're doing. So now we're in the DTI Printed Electronics Laboratory here in Tostrup in Denmark. So actually I have a lot of things going on behind me, but so I'm just going to give a sort of a very quick sort of overview of the different equipments and what we can and what, you know, the sort of capabilities we have at our disposal. So right behind me, the first thing you see on the right hand side is a hot press, and this is actually a very versatile piece of equipment that we need for doing transfer of electronics onto, for example, textiles. So what we do is we print onto transfer foils, PET foils, and then we're using equipment like this and this is actually quite a large area to be able to transfer them into large, sort of the whole entire, you know, sort of electronic prints, and then, you know, print and transfer onto, yeah, textiles. We can also do plastics and polymers and composites, etc. So this is a very nice, versatile tool. Then I'm going to take you with me to the next equipment. This is actually a French pick and place machine that we use for both doing dispensing, but also pick and place of components. In this case, we have a dispensing head and a pick and place head, where we can then dispense adhesives, pick and place the components, SMD, LEDs, microcontroller ICs, etc. And we can also then encapsulate with different types of post-process adhesives as well. This is a very nice manual machine. It can't do huge volumes, but for prototyping and maybe small scale manufacturing, it's a very nice and versatile tool. Then I'm going to go over here to the on the other hand, the other side, which is my colleague is working with our PulseForge Invent machine, the photonic curing system. And this is also a very versatile tool for sintering of nanoparticle-based inks like nano silver, nano copper. Right now, Christian is working with the development of our own screen printable copper based inks. So we're using a photonic sintering for that sintering process. And it's a very nice way to sort of alleviate the challenges of having high temperatures and also long curing times, which you have typically with IR and convection oven curing. This can actually cure things in a matter of seconds instead of minutes or tens of minutes. So this is a very nice tool to have. Then I'm going to turn around. So now I have the advanced deposition tool, and this is a tool that we purchased some years ago. This is an F series from Cereprint, Cereprint F series advanced deposition tool. So in this case, we have a Konica Minolta industrial inkjet print head. We have two Dematic DMC print heads, and we also have an Optimic aerosol jet print head in this tool. So we can actually, in principle, print up to 4 materials at the same time. On the back of the machine, we have NIR and UV curing, so we can actually do printing, curing, and then printing, curing. So we can actually build up layer by layer without the need for taking the substrate out of the machine. So this is a very versatile tool, which is really, really good for prototyping and process development, and also device development. So this is a very nice machine. Then we're going to go a little bit further. So what you see here on behind me is sort of the setup we use for testing and characterization. So in the very back, we have the climate chamber. This is going from -40 to 80 degrees Celsius, and we can also go from almost 0 to 90% humidity. So this is very good for the standardized climate testing. And what you see here in the right next door to it is the electronic rack, which is used to do real-time measurements. So we can actually measure in real time how humidity, temperature is affecting printed structures, printed components. On the table here is also a setup for doing mechanical measurements. So all the bend testing, stretch testing, all these other things. So when you're talking about foils or stretchables, and when you go to ink textiles, this is all we have, all the equipment, which is also, again, measuring and recording in real time. So we can actually do stretch testing in real time. So this is a very nice setup for understanding how inks react when you're stretching them thousands of times, for example. Quite unique. Then behind me, the last thing I want to show you is our industrial print line for pilot production. So this is an Indo print system, which has a printing system, and then behind it a conveyor belt oven system, which has IR and convection oven curing. And this is actually printing on very large 80 by 50 centimeter print size. We can print up in this size, and you can see what they're doing now is some preparing some printing for TPU, which is going into some wearable applications that we are doing here at DTI. So with that, that's a very quick review of what we have. Of course, we have quite a lot of other infrastructure, but just to give you a sort of a taste of what we could do here. So now I'm going to give the word back to Christian, and then I'm going to actually run over to the other lab, and then we'll see you again in a few seconds. Christian, can you take over or come back? All right, thanks.
I'm back, and thank you, Zach, for a very impressive tour in the lab. I hope people enjoyed, and it gave you an impression of what kind of capabilities we have here at the Danish Technological Institute in Denmark. What I will showcase now is some of the application that we are working in. One of the current application is a sleeve that is used for measuring EMG, and these are typical application, wearable application, where you have a sensing sheet, or you have a sensing unit that should obtain skin electrodes, or work as skin electrodes. And this is an area where printed electronics is so amazing, because we can substitute silver-based fabric, or we can substitute materials which are typically used with silver. Another application is one which I have also been involved with, is a muscle monitoring system that includes both near-infrared spectroscopy, and it includes the measurement of EMG signals. This was originally built for the European Space Agency, but again, the application is very, very similar to other type of wearables, where we see there is an element of softness, there is an element of integration of devices that or plates that can use as skin as a skin contacting unit. Finally, I will also showcase this diaper. Yeah, you can't imagine, but this is an electronic diaper that use printed electronics to measure the humidity in the diaper, and it sends a signal to a mobile device, which can be used then to improve the health care and the care taking. Finally, I will showcase also what we see very often is shirts with EMG or EKG measurement with respiration. And here you can also imagine that printed electronic will have a huge benefit. Our approach to printed electronics is not only to understand how printed electronics can be used as a technology, but also to see how it can work into applications. What I'll do now is I'll share some of the presentation on standardization, because you can imagine that standardization is a very important issue to progress in this field. One of the main issue, of course, here is that often building wearable application or building application where you have a hybrid technology integration is how to separate things so that you don't necessarily need to build everything from scratch. You don't necessarily need to build both the skin sensor, both the electronic, both the mobile application, both the the cloud application, but to separate things into a specific area that has a fine-tuned supply chain. And one of the area clearly is how can we build a connected solution so that the electronics is separated from the built-in or the element that are included into a sleeve or a shirt. So that's an element where standardization is highly important. I will say that in the past, many have worked with standardization, and one of the good examples is clearly USB and the thought on how to create a community of people or companies that work together on a technology that is standardized but not necessarily owned by one partner. And that's a work that I do on the Smart Textile Alliance, and hopefully we can be successful in creating a momentum for the whole industry by understanding standardization. Finally, I want to explain how you operate when you interfere with the Danish Technological Institute. We see our role really as being a contract developers based on the technology, the base technology on inks, based on application, and provide services. So I hope I can just now show how an application would work by letting Zach demonstrate a application. And please go ahead.
All right. Yeah, I'm back.
Yeah.
As you can see. So, so what you're seeing here is, well, on my arm is the Precure. Yeah, perfect. So the Precure sleeve, and the Precure sleeve has on the inside a printed EMG electrodes, and on the outside is a dongle, which is doing the sort of the data sort of measurement and also transferring it to my mobile phone, which is going on the screen. So when I start to
flex my muscles, then it starts to react. So really, this is a very nice sort of real-time solution. So yeah, I guess that's kind of that's telling us about how we can integrate printed EMG electrodes into sleep, how we can get it to work in a real live demo. We have also been able to accomplish very high resistance to, for example, washability, 50 washes, stretching, taking on and off hundreds of times. So trying to really alleviate all the very harsh specifications from the end user, and then solve them with the printed electronic solution.
Yeah.
So, yeah.
We hope that we have given you an idea of how printed electronics can be utilized in smart wearables and what capability we can offer here at the Danish Technological Institute. Please visit our booth and please get in touch with us.
All right. Thank you very much.
Christoph is happy and we are happy.
So we started 2 minutes early. Of course, we are delayed already, but
this 5 minutes of your time.
No, awesome presentation. Well done, guys. If you want to visit Danish Technological Institute, they are in room E, and they are happy to talk to you at any point of the day today. With that, Christian, Zach, well done. Pleasure having you around.